As shown in the figure, the distance between the two horizontal planes, which represented by the dashed line, is h. And there is a uniform electric field with a direction horizontal to the right in the area between them. From point A above this area, the charge balls M and N are launched successively with the same initial velocity in the direction parallel to the electric field. The balls enter the electric field area under the action of gravity and leave from the lower boundary of the area. And the mass are the same, which is M, and the charges are Q and negative Q, respectively. It is known that the speed direction of N when it leaves the electric field is vertically downward. M moves in a straight line in the electric field, and the kinetic energy when it just leaves the electric field is 1.5 times the kinetic energy of N when it just leaves the electric field. Disregarding air resistance, the acceleration due to gravity is g. So the first question is asking about the ratio of the displacement of M and N in the horizontal direction in the electric field. Since M and N put like in the vertical direction, the initial velocity for M and N is the same, which is 0. The acceleration is the same, which is g, and even the vertically displacement is the same. So we can make two things happen at the same time, and it takes the same time. That is, they end at the same time. So we set the same time to t because their charges are exactly opposite. They accelerate with the same amount, but in opposite direction. That is, m moves horizontally to the right with uniform acceleration, and n moves horizontally with uniform deceleration. When n leaves the electric field, its speed is only in the vertical direction, so the horizontal speed is 0. We can use the formula for acceleration to represent the displacement of m and n. At this time, we have three formulas. So we can directly calculate the ratio of the displacement of m to the displacement of n, but we have a better method. We can draw an image with time as the abscissa and velocity as the ordinate. The area of these images, which is time multiplied by velocity, is the displacement. So we can see for identical triangles, and we can prove that they are the same. These three triangles are the displacement of m, and this triangle is the displacement of n. So we can say that the displacement of m is 3 times of n. The first question is over. The second question is asking about the height of the point A from the boundary of the electric field. M is a M moves in a straight line when leaving point B. So we can derive this formula based on this information. It is very clear that speed and energy are completely different things, but the ratio between them is the same, right? And we can also convert the angle into the formula. The second formula is, well, acceleration formula, but this time we use it in the vertical direction. The third formula is the free fall formula. The fourth is what we derive using Newton's second law and electricity force. And because the terminal velocity of n is 0, so we can draw this conclusion. From the first formula, we can multiply the denominator by the numerator and the numerator by the denominator. And we can get this new formula and we put it into the second formula and we can get this, which we only have H and capital H right here. So we get the H. The second question is over. The third question is asking about the electric field, intensity of the electric field. So from the second question, we know more about vertical displacement. For the third question, we can start with an interesting fact. So in the image, we can base it on the area ratio is equal to the square of the side length ratio to prove that the time period right here are the same, right? Because if this is 1/2, then they are both 1, which is t. And well, because they are the same, so I can use the image I used in the first question, which is this. And the section in this section in the image is t. So for example, in the second formula here, what I can actually do is I can find the area of this. So I just use the formula of calculating triangle's area. And the First equation is the distance of free fall. In the third formula, because the horizontal kinetic energy of point N is 0 after leaving the electric field, we can refer that the horizontal kinetic energy of N cancel out the energy of the electric field, which is the same. So there is still a piece of information we did not use, which is the kinetic energy of M when it just leaves the electric field is 1.5 times the kinetic energy of N when it just leaves the electric field. So we can derive this because it's reasonable that we curious about the actual ratio between the two, right? So according to what I just mentioned, the formula below puts the free fall and ordinary calculation of energy on both sides. So the question is asking about electric field intensity, which is E. Now we have a total of 5 formulas. We first find the X of the fourth formula right here. We can find the X. And the fifth formula is the only one with E, which is what we're gonna find. So we can substitute the X to this equation and we can get E.